Okay, this is the 25-minute problem from FRQ 8. So same as the other ones, was generated with a 15-point rubric that I will walk through as we walk through these problems. I like this particular one. It gives you a good chance to practice a lot of derivative aspects, review how to write an equation of the tangent line, as well as includes a normal line, which we first defined back in Unit 2, it would have been 2.5 is where we remembered or reminded ourselves of how to do a normal line. I believe it was also on your fall final, if I remember correctly, as well as, I think we did one, yes, there was a multiple choice question. I believe on sample exam 1, might have been sample exam 2. So just listing out some of the other places you could look, or if you're having trouble finding them, like I have said many times, email me. I'm definitely still here to support you in locating whatever information it is you are trying to find. Okay, so as we've said over the course of all of the different videos, this year's AP test will not have a calculator required, although you will be allowed to use one, but you still need to make sure you are showing all of your work, but you will not have to use your calculator. And so that's why that's notated here. You will have a 15-minute and a 25-minute question with 5 minutes following that 15 and 25 in which to upload your work. You do need to make sure that you have hit submit before the end of that 5-minute upload period, or else it won't be counted. So do make sure you have hit submit in time. Okay, here we go. F of x and g of x are twice differentiable functions. Specific values of f of x, f prime of x, and f double prime of x, as well as g of x, g prime, and g double prime are shown in this table below. So we have a ton of information here at our disposal. Part A says, if p of x equals f of x times g of x, find the value of p prime of 1, then find the equation of the line tangent to p of x at the point x equals 1. So we have done, I don't even know at this point how many problems involving that set of instructions. So one more time, that set of instructions should cue y minus y1 equals m times x minus x1. We are looking to set up our equation of our tangent line and then leave it alone, call it good. We've got our equation. Okay, so we need to find our x1, y1, and slope. So first off, we have an x1 already. Our x1 in this particular case is 1. They told us that here. Okay, don't know my slope yet. We need a y1. They did not give me a y1, so I somehow need to find a y1. Okay, well, how do you find y when you've got x? Okay, well, you plug it into your original equation, right? That's where your y is found. Y is always your original equation. So in this case, we're going to be plugging our x equals 1 into p. Okay? Well, p is f times g, and in this case, it's going to be f times g at 1. And so f of 1, looking at our table, f of 1, there's f, there's 1. F of 1, therefore, is 3. G of 1, G1 is also 3. And so my y1 is 9. Okay, slope. How do you find slope at the tangent line again? Okay, well, slope is a derivative. So to find my slope, I do need to take the derivative of my function. So p prime of x equals, and we're taking the derivative of f times g. Well, what rule is at play there? Okay, that would be product rule, two things multiplied together. So we've got our 1, f of x, d2, g prime of x, plus 2, g of x, d1, f prime of x. And so then to find my slope, I am plugging in my x equals 1 here. So we have f of 1, g prime of 1, plus g of 1, f prime of 1. F of 1 is 3. G prime of 1 is 9. G of 1 is 3. F prime of 1 is negative 1, which is 27 minus 3, or 24, and so that is my slope there. Okay? This one was worth 4 points. 1 for doing product rule, 1 for finding p prime of 1, one for finding P of 1, and one for your equation, with potential for partial credit at different points in this problem, as has been the case with every video we've done, or that I've walked through. I've reiterated the fact that if you make an error earlier on, but you use that error and continue to do the problem correctly, reflecting that error, even though the rest of your work now technically is wrong because you made an earlier mistake, you could still earn other points. They wouldn't double dock you, right, as long as you haven't oversimplified the problem. And so as always, if there's questions on partial credit and you're like, I don't know if I would get, or how many points I would get here, or whatever the case may be, feel free to send me an email. I'm definitely happy to clarify that for you. Okay? Okay, B, if Q of x equals f of x over g of x, find the value of Q prime of 2. Then find the equation of the line that is normal to Q of x. So, equation of the line, we are again thinking y minus y1 equals m times x minus x1, but normal, remember the definition of normal is perpendicular, and so we are going to be thinking opposite reciprocal, I'll do that, just REC, reciprocal slope for normal here, okay? But everything else is going to be pretty much exactly like part A. Okay, so my x1 first off is 2 in this particular case, x minus 2. Still don't know my slope, still don't know my y, so same thing, how do we find our y? Well, we get it by plugging into our original function, so let's go ahead and do q of 2. Q of 2 is f of 2 over g of 2. F of 2, here's f, 2 is 0, g of 2 is 1, 0 divided by 1 is 0. So you could also just write y equals, you don't have to write y minus 0 equals, right? And then slope again is your derivative, so we have q prime of x. So how do we take the derivative of f of x over g of x? Well, that would be quotient rule, so we've got low g of x d high minus high d low all over low squared. And so then our slope is that q prime with 2 plugged in. So we're looking at g of 2, which is 1, times f prime of 2, which is 3, minus f of 2, which is 0, times g prime of 2, which is negative 2, all over g of 2, which is 1, squared, which is still 1, which is 3, minus 0 over 1, which is just 3, okay? I actually shouldn't call that m, because m, remember, is going to be the opposite reciprocal. And so opposite would be negative, reciprocal would be 1/3. And so that would be my slope here. Okay? Essentially the same 4 points are available here. One comes from the quotient rule, so this element here. One comes from finding q prime of 2, the 3. One comes from the 0, and one comes from your equation. Which does mean for the equation point, you did need to do opposite reciprocal on your slope. Right? You did need to have negative 1/3 there. Okay, part C, we have, if c of x is f of g of x, find the value of c prime of 1, then find the equation of the line tangent. So I'm not going to write that y minus y1 again, but that's what we're thinking, right, to c of x at the point when x equals 1. Okay, so we have y minus our y1 equals m times x minus our x1, which is 1. How do we find the y when it's not given? We plug into our original, so c of 1 is f of g of 1. G of 1 is 3. So this becomes f of 3. F of 3 is negative 2. So this is c minus negative 2. Okay? And then slope. Slope is your derivative. What rule are we using to take the derivative of this c of x? Okay, well this is chain rule. We have a function inside another function, so derivative of the outside, leave the guts alone, times the derivative of the guts. And so then your slope is C prime of 1 is F prime of G of 1 times G prime of 1. G of 1 here is, there's G, there's 1, 3. G prime of 1, G prime 1 is 9. And F prime of 3, F prime 3 is 1. 1 times 9 is 9. Again, it's worth 4 points. 1 for your chain rule, 1 for C of 1, 1 for C prime of 1, and 1 for your equation with, again, one more time, opportunities for partial credit. Okay, last but not least, we have part D, which is going to be worth a total of 3 points. Okay, I'm going to work it out one way here on the video, but on the answer key, I did work it out 2 different ways. I'll mention those 2 ways as I walk through this, so that if you did it the other way, you can look at the answer key, or if looking at the answer key, you still have a question, like I said, as always, send me an email. I'm happy to make another little video for you or explain it or whatever the case may be. Like I said, just let me know. Okay, so G double prime of 2x. This one here, there's a chain rule component. We can't do chain rule within an integral, no product, no quotient, no chain, so we do have to do a u du substitution. Okay, so my u here would be 2x. My du would be 2 dx. Dividing that 2 over, we would be able to do our u du substitution. Okay. As we've said many times over the course of this year, you have an option here. You can change your bounds to make them u bounds, but if you do, then you have to make sure you don't plug 2x back in. Or you could integrate already. Integral of g double prime is g prime, and you could call it g prime of 2x and just have this 1/2 out front. But if you call it g prime of 2x, then you need to make sure you leave your bounds as 0 to 1. Okay? I'm going to walk through it changing the bounds for those who would like that verbally reminded. It was also on one of your, or a couple of your multiple choice ones as we've been practicing those. And then, like I said, if you did it the other way, I will also have that worked out on my answer key so you can take a look. Changing your bounds, you'd be taking this 1, which is an x bound, and plugging it into x to turn it into a u bound. So 2 times 1 is 2. Plugging the 0, 2 times 0 is 0. Okay? Integrating then, integral of g double prime is g prime. Plugging in your upper, you have g prime of 2 minus plugging in your lower, g prime of 0. Okay. G prime of 2 then, up in the table, here's g prime, 2 is negative 2. Minus g prime of 0, up here in the table, g prime 0 is negative 5. And then again, one more time, you don't have to simplify anything, so I'd leave it there. But if you did simplify, this would be negative 2 halves plus 5 halves, which is 3 halves. Okay, this one was worth 3 points. 1 was for the u du substitution element, which you did not have to, for the record, show. You didn't have to show u du. You needed to make sure a 1/2 made its way into the problem, though. Right? And so that 1/2 element, recognizing that there's a u du component to it, would need to be there. 1 was for the antiderivative, which was getting the g prime from g double prime. And 1 was for your answer. Okay? Okay, if there are any questions on grading or the problem in general, or the 2 from before this, the 15-minute ones, send me an email. I'm here to answer your questions.